Hey everybody, welcome to this week's lecture. In this lecture, we're going to be talking about the introduction to natural language processing. We'll talk about various topics. We'll talk about a case study. We'll talk about concepts that you may or may not be familiar with. So without further ado, let's just jump right into it. So section 1 is going to focus on the fundamentals of NLP and some of the foundational learnings. So before we dive into any of the concepts, let's first set the stage for our learning objectives that we have in this section. First, we'll define what NLP actually is. While you may already know some of the basic understandings of it, we're going to refine we're going to refine the understanding of it and see how NLP fits within the broader scope of the AI field. Next, we'll explore the historical evolutions of NLP, understanding that the progression from a rule-based system to more of a modern machine learning techniques will help us appreciate the current state of the field and anticipate future trends that we might potentially see. Finally, in this section, we'll then break down the key components of the language, syntax, semantics, and some other very important things that we'll cover. That essentially builds the building blocks within the NLP systems. By the end of this section specifically, you should have a solid foundation of these understanding concepts, and we'll continue to build on it as we continue on through this lecture. First, let's start with what a clear definition of NLP is. So natural language processing is a branch of artificial intelligence that deals within the interactions between computers and humans using natural languages, essentially how we communicate in everyday lives. This interaction is far from trivial because human language is incredibly complex, as you may know, filled with multiple different assumptions and ambiguity, and it depends on the context in which that you're saying a word. The scope of NLP is broad itself. It includes developing algorithms, models that allows computers to understand, interpret, and even generate human languages. Think about the last time that you use a voice assistant like Siri or Alexa. When you relied on Google Translate. These are all different examples of NLP at work. As we progress through this course, we'll dive deeper into how these techniques are built and how they function. Understanding what NLP is and its goals set the stage for appreciating the challenges and innovations we'll be exploring within the next coming slides. Now that we have a working definition of what NLP is, it is important to understand how the field has evolved over time. This historical context will help you appreciate why certain approaches are used today and how innovations have shaped the field. In the early days of NLP, from the 1950s to the 1980s, the field was dominated more so by rule-based systems. These systems rely heavily on handcrafted rules. Essentially, programmers would specifically write rules to handle different linguistic situations. While this worked to some extent, it is incredibly labor-intensive. Imagine having to sit there and write a response for every single question that may appear within NLP in every such a situation. As we move into the 1900s and early 2000s, there was a significant shift towards statistical NLP. This approach leveraged large amounts of data and statistical models to predict linguistic patterns. Instead of relying on rigid rules, systems begin to learn from the data, making them more adaptable and capable of handling a broader range of language inputs. However, the real revolution came in the 2010s with the advent of machine learning and more recently, deep learning. Neural networks and essentially transformer models like BERT or GPTs have dramatically improve the accuracy and capabilities of the NLP systems. These models can understand context, generate coherent text, and even perform complex tasks like translating and summarizing, all within unfathomable levels of accuracy and time. This shift to deep learning has truly transformed the NLP into the most exciting and rapid advancement within the field of AI. Understanding these evolutions gives us a roadmap for what we are going to talk about next and how NLP might be heading, where NLP might be heading within the future. Cool. Next, we'll understand, with an understanding of the NLP's evolution and the definition, now let's focus on the fundamental components of the language that NLP systems must handle. Human languages is a rich and complex, and for computers to effectively process it, they need to understand these key components: syntax, semantics, and pragmatics. Syntax refers to the structure of sentences. It is all about how words are arranged according to a grammatical rule. For example, in English, a simple sentence structure follows the subject, verb, object order. Understanding syntax is crucial for tasks like parsings, where the goal is to determine the grammatical structure of a sentence. Parsing is super big, and if you want an example of that, a lot of these resume systems are parsing information to fit in within fields. So if you use stuff like Workday, if you ever uploaded your resume, you'll see how it will be able to pick certain words, and it'll know exactly where to put them. So like job history, experience, education. Semantics is about the meaning. It's about just enough for a computer to recognize a word. It needs to understand what those words mean. This involves everything from identifying the correct meaning of a word in the context, like whether bank refers to a financial institution or the side of a river, to understand the relationship between these words within a sentence. Paragrammatics goes to a step further and deals with the context in which languages used it. Words and sentences can have different meanings depending on the situation or the speaker's intent. For example, the sentence, "Can you pass the salt?" is technically a question, but paragrammatically, it is a polite request. In addition to semantics, syntax, and paragrammatics, it's important to consider phonology, the study of the structure and formation of words. Phonology examines how words are constructed from the smaller unit called phonetics, which includes roots, prefixes, and suffixes. For example, the word unhappiness is made of three phonetics: un, happy, and ness. Each of these contributes to the overall meaning of the word. Understanding this is a crucial part of NLP for tasks like limitations, where we consider the photogrammatical structure to find the root form of the words. It is also essential to building models that can understand and generate language with the correct grammar and word forms, rather just spitting out very grammatically incorrect forms. So next, we'll talk about how this looks. So here's a diagram of kind of how everything works and where does it mean. What are the important things about it? Definitely check out the link for more sources. So now let's talk about the challenges within NLP. So while NLP has made tremendous strides, it is important to recognize that the challenges that come from processing human languages is inherently ambiguous, which means that the words and sentences can often have multiple meanings. For instances, the word bat could refer to a flying mammal or a piece of sports equipment, and it's up to the NLP systems to determine the correct meaning based on the context. Context is another major challenge for NLP systems. The meaning of a word can change depending on how they are used. For example, the phrase "I saw her duck" could mean that you saw a woman lower her head to avoid something, or it could mean that you saw her pet bird, the duck, the actual duck. Understanding context is essential for correctly interpreting sentences such as these. Lastly, we deal with the unstructured data. Unstructured data refers to the data that is not neatly organized within tables or spreadsheets. Human language is a messy thing. People don't follow grammatical rules. They use slang they use abbreviation, they even use emojis. This lack of structure makes it difficult for computers to process language accurately and consistently. These challenges, ambiguity, context, understanding, and dealing with unstructured data are the heart of NLP and what makes them effective. And it also provides the challenges for them. Their drive undergoes research and innovation within the field. And as we continue to strive for systems that are more capable and handle more complex human languages, we need to understand how we can move forward. And as we move forward in the course, we'll explore different techniques and models that have been developed to tackle these challenges. Next, let's talk about section 2, and this is the applications and techniques within NLP. In this section, we have 3 primary objectives here. First, we'll explore various real-world applications of NLP. These examples will help you see how NLP is embedded in technology that are all parts of our daily lives. Next, we'll break down the NLP pipeline, a step-by-step process that NLP systems follow to convert raw data, raw text, into actionable insights and responses. Finally, we'll introduce some basic language models, including the N-gram model, which will serve as a foundation for more advanced topics later on within the course. By the end of this section, you'll be able to practically understand how NLP works within its applications. So here's some real-world examples. NLP has a wide variety of applications that have become integrated to many technologies that we use today. Let's start with machine translation, an area where NLP has had the most profound impact. Services like Google Translate uses this systematic NLP models to convert text from one language to another. While translating quality has improved significantly over the years, there's still a lot of challenges, and particularly when it comes to capturing cultural notions and expressions. Next, speech recognition. The underlying technology uses a language model to understand and interpret speech, even in a noisy environment or using a vast variety of accents. Next is semantic analysis, and we'll do an example of this in a little bit. It's widely used in areas like social media monitoring, where businesses analyze public opinions and customer feedbacks. By identifying the semantics between tweets, reviews, commas, companies can then gain insights into how their products or services are perceived. Next is chatbots and virtual assistants, one that we'll talk about much more later on. These have become increasingly common within customer service and personal assistants. These systems use NLP to understand the responses to users' queries, perform tasks, and even engage in conversations that mimic human interaction. They are particularly useful in handling repetitive inquiries, freeing up human agents to then tackle more complex issues. Finally, another example is informative retrieval. Is a fundamental aspect of NLP. Research engines like Google rely on NLP technologies to then parse and rank information, helping users find relevant content quickly and accurately. These systems analyze the text and web pages that matches the user's queries, considering factors like like keywords, relevancy, context, and even users' intent and location and previous history. To understand how NLP systems process language, we need to look at the NLP pipeline, a series of steps that raw text goes through to understand something a computer can understand as well. The first step is text pre-processing, where the raw text is cleaned and prepared for analyzing. This involves tokenization, breaking down text into individual words or phrases. Stemming is reducing the words to their base or root form. And lemmaization takes into account the photogrammatic structure to return words to their base form. These steps are crucial because they are standardizing the text, making it easier for the system to understand. Next, we move on to syntactic analysis, where the structure of a sentence is examined. Parts of speech tagging assigns grammatical labels to words like nouns, verbs, adjectives, while parsing breaks down the sentence structure helping the systems understand the grammatical relationship between the words. Semantic analysis is where the system starts to interpret meaning. This includes tasks like name entity recognition, NER, where the system identifies and categorizes entitles such as names of people, organization, locations, etc., within the text. Semantic analysis also falls under this category, where the system then takes the emotional tone of the text. The final layer is pragmatic analysis, which deals with understanding the text in the language that it is used. For example, understanding whether a question like, can you pass the salt, is a request rather than a literal question about the capacity. This step is essential for more complex NLP tasks like dialogue systems, where understanding context and intent is crucial. These steps are the foundation of the application of NLP within the real-world situations, such as machine translation, question-answer systems, dialogue systems. By processing text through these stages, NLP systems can then perform a wide range of language-related tasks with increasing accuracy and cohesion. Now that we've covered the NLP pipeline, let's introduce one of the core concepts that power many of the NLP tasks: language models. A language model is a statistical model that predicts the next word in a sequence based on the words that have come before it. The simple example is the n-gram model, which considers the previous n-note word to predict the next word. For instance, the biogram model, where n equals 2, the model predicts the next word based on the previous one. So think about when you're using your phone and then you have these predicted text. This is what it's referring to. While the N model are useful, they have limitations, essentially with long-range dependencies, meaning that they struggle to consider the context that spans across many words or sentences. This is where more advanced models like the transmitters come in. BERT, or the bidirectional encoder representation from transformations, and GPTs, which is the generative pre-trained transmitters, are examples of this model that have revolutionized NLP. If you think of ChatGPT, this is one of those examples. By allowing the systems to understand and generate text with such great accuracy, these models consider the entire sentence or even multiple sentences at once rather than just word by word. Now that we have an understanding of the NLP pipeline, let's apply it to a real-world scenario: the sentiment analysis on Twitter data. To help us follow along, I've created a Google Sheets with this example here that we can walk through together. So if you want to walk through this together, click on that link right here, and it'll bring up to the screen right here. So we'll begin by talking about the data collected within this sheet. And here we've gathered a small set of tweets referring to a specific product launch in this example. These tweets include various sentiments from positive to negative. These tweets identified by a Twitter _ID, as you see right here. So these are all the different ones right here. And next, we've captured the username. So an example here, username, and then the tweet content within itself. So here, as you see, I absolutely love this new product, #awesome. For the objective of this step specifically, the model then has to go and collect the representation samples. And then by analyzing the sentiment, this data will then understand the fundamentals of the next following one. So what happens here is then we do what is called pre-processing, as we mentioned, right? So for this one, we're going to clean up any raw data and prepare it for the analysis itself. So the pre-processing involves several key steps. Tokenization, right? We're breaking it down into individual words or tokens. Next is what's called a stop word removal. Just filter out any common words like the word the or is that do not contribute much to the sentiment. Next, what we're going to do is we're going to remove we're going to reduce some of the words into their root form. And this is stemming, this is called stemming. So in our sheet here, as you can see, that we've cleaned up some of the tweets and removed some of the hashtag URLs and any special characters that they had previously. And we want to standardize it to more of a just text form. For example, I love the new product, hashtag awesome becomes absolutely love new product, awesome, right? We remove the hashtag, remove the I. Next, we move what is called feature extraction. So within this one, we then convert the clean text into numeral features that our sentiment analysis model can then work with and actually produce for. So for simplicity, we built a basic approach: positive words, negative words, and then total words. Let me go back. So for this example, the tweet absolutely love new product awesome. The positive underscore word column then results into 2 because 2 positives. And then while the negative count is 0 because there wasn't anything negative within this analysis itself. This step is really crucial because it then translates text into structured form that it could be read within a machine language. And then from there, we move on to the results and insights, as you can see here. This sheet actually helps clarify the sentiment analysis based on some features that we've extracted. So we've classified, again, positive, neutral, negative. And here you can see that there's how many counts of it, 2, 1, and 2, and then the percentage that it makes up for it as well. We use a simple rule or machine learning model to assign 3 of these labels. More advanced models will then actually go deeper into it, but in this example, we went from understanding how a computer would operate given this information, and then the end results come over here. So this is how they kind of read it: what is a positive and a negative, and what is a neutral. In more advanced ways, there are features that we can add into Google App Scripts to then actually figure this out. But models, just for this example, I just wanted to keep it very, very simple. Great. So we're in section 3 now. We'll talk about the future trends and ethical considerations within NLP. So in this section, our primary objective is our threefolds, right? First, we'll identify and discuss some of the emerging trends within NLP that are pursuing some of the boundaries that the systems can do. Next, we'll address the ethical considerations. These are crucial because NLP systems can become more integrated within our lives, and we need to think about them more critically and understand potential risks and challenges. And then finally, we'll discuss the broader implications of NLP and AI in society, and consider both as an opportunity and a potential pitfalls as we look into the future. So in the field of NLP is evolving rapidly, and with several of the key trends and emerging, there is a lot of promise within this world, in this industry. One of the most significant trends is it's called transfer languaging. It's called transfer learning. This approach involves pre-trained models like BERT or GPT, which have been trained on large databases and fine-tuned them for specific tasks. The beauty of these transfer learning is that it allows us to leverage the vast amount of knowledge that these models have acquired and apply it to niche tasks with multiple smaller data sets. This trend has made a state-of-the-art NLP access more accessible to the wider range of people and applications. Another exciting development within here is the multimodal NLP. Traditional NLP deals primarily with text, but multimodal NLP integrates text with other types of data, such as images, audios, videos. For example, multimodal systems could analyze a news article that includes both text and images, providing a more comprehensive understanding of the text. This is particularly relevant for applications like social media analysis, where posts often include images and text together. NLP is a low-resolution language, low resource language, and another crucial area. While most NLP advances have focused on high resources languages like English, there's a growing effort to develop models that work well for low resource languages that don't have language databases available. This is crucial for making NLPs more inclusive and emerging that speakers of all kinds that are less widely known languages can benefit from. Finally, few-shot and zero-shot learning are methods that allow models to perform tasks with very few or no specific examples. For instance, a zero-shot learning model might be able to translate a sentence into a language that it has never learned or seen before, leveraging his understanding of the language structure. This approach is opening up a new possibility of NLP application where data is scarce or expensive to obtain. These trends are pushing the boundaries of NLP, making it more volatile, more inclusive, and more powerful. However, these advantages don't come without their challenges and unethical considerations that we'll discuss right now. So some ethical considerations is that as NLP technology advances, it is essential to address the ethical consideration that comes with it. And one of the most pressing issues is biases within the NLP models. Since these models are often trained on large data sets, sources from the internet, they can inadvertently learn and propagate from biases presented within the data. For example, a model might generate biases or stereotype languages when asked to describe a certain group of people. The impact of such biases can be significant, leading to unfair or discriminatory outcomes in applications like hiring tools or content monitoring. So mitigating biases requires a multiple phase approach. This includes really diversifying and the representation of the data sets itself, implementing biases detection and correction techniques, and continuously monitoring the model's output for unintended consequences is an ongoing challenge that a lot of developers are dealing with in a lot of companies. But it's crucial for NLP systems that are unfair and unjust. Another crucial concern is privacy. NLP applications often require access to sensitive personal data, such as emails, messages, even voice recordings. Ensuring that this data is used responsibly and securely is paramount. Techniques like differentiating privacies where noise is added to data to prevent individual identity and encryptions can help safeguard users' privacy. However, balancing the data utilization and privacy delicacy is an area that requires a lot more focus. Now, looking into the future, NLP is a set that plays a pivotal role in the broader field of AI. And as NLP continues to improve, it is increasingly being integrated with our AI fields, such as computer vision, robotics. For instance, imagine a robot that can not only navigate a physical space, but also understand and respond to complex verbal instructions, such as I think Ray-Ban and Meta collaborated on the Ray-Ban glasses. This integration opens up a new possibilities for creating AI systems that are more volatile and capable of interacting with humans in natural and intuitive ways. The potential social impact that we have to consider here of these advancements is just unheard of. And healthcare NLP can be used to analyze patient records, streamline diagnosis, and even assist in mental health treatment through conversational agents. In education, NLP can provide personalized learning experience, helping in language learning and support students with disabilities. Automation is another area where NLP is making waves, from automating customer service to enhancing productivity tools with smarter text suggestions and summarization. However, as we look to the powerful technology that we have here, there are challenges and opportunities. One of the key challenges is bridging the gap between research and real-world application. While research labs are producing increasingly significant NLP models, deploying these models in real-world settings require careful consideration, as we mentioned before, and factors like scalability, robustness, and ethical implications. On the other hand, the opportunities are vast. NLP has a potential to revolutionize in industries, improve accessibilities, and enhance human-computer interaction, or HCI, in ways that we haven't even been able to explore. And as we move forward within this course, a lot of things that you'll see is that it's super important to be both optimistic and about the possibilities and cautious of the things that we're building. The decision that we make today will revolutionize the future and shape the differences within the NLP world and as AI as a whole. Questions, concerns, feel free to reach out. Take care.